basically tonight we're going to look at spontaneity. So we're going to kind of look back at delta G, and how does stuff in electrochemistry relate back to delta G into K, equilibrium constants, and kind of just look at units in general for units we'll be using. So basically Roman letter 3, and we're just going to name this section Spontaneity of Redox Reactions. Alright, and we're going to start off just with letter A and talk about some units. Alright, so we're going to start off by talking about electrical energy. And electrical energy is just like any energy in chemistry. And any energy in chemistry has the units of joules. So electrical energy is measured in joules. And to get this, you just need to know that joules are equal to volts, which we talked about in the podcast 14.1, times coulombs. I'll talk about coulombs here in a second. So coulombs. And the other thing you need to know is a Faraday, and a Faraday is a unit, and 1 Faraday is equal to 96,500 coulombs per mole of electrons. Alright, and that's pretty much what we're going to stick with for now. So letter B is simply going to be spontaneity, and just like spontaneity always relates back to delta G. So a little bit of reminder from thermochem, spontaneity has to do with delta G. If delta G is negative, it is spontaneous. We'll kind of clean that up a little bit. If we have a negative delta G, we have a spontaneous reaction. And if delta G is positive, we have a non-spontaneous reaction. Alright? And again, delta G is both a combination of delta H and delta S, with the equation delta G equals delta H minus T delta S. Alright, so with that, our relationship between G and E is this. Delta G naught, and the little naught just means standard conditions, equals negative N, which is number of moles, times Faraday's constant, alright, which is 96,500 coulombs per mole, times E cell, which again is what we were calculating yesterday, or in podcast 14.1, and that relates E to G for us. Alright, so again, it is a relationship between E and delta G. So, with that relationship, we can easily see that negative G values, negative delta G's, come from positive E cells. Alright? Because a positive E cell, Faraday's constant is always a positive, moles is always going to be positive, it's not changing moles, it's just moles. It's really the moles of electrons we are transferring. Alright? So every N and F are F is our constant, N is always going to be positive, so a positive E gives us a negative G. Or a positive G comes from a negative E. From negative E cells. Alright? So, with that, we talked about yesterday, or in our previous podcast, that galvanic cells are always positive. So real quick, positive E cells are galvanic cells, okay? And galvanic or voltaic. If it is a negative E cell, it is not a galvanic cell, because galvanic cells are spontaneous. Again, we highlighted that yesterday with our little highlighter. So again, galvanic cells are spontaneous. Alright, that would be good to have in your notes. All right. The next thing we're going to look at is just a calculation, a little example using this. So we're going to use our example from 14.1 because it should just be in your notes. And if you looked at our zinc copper cell, it should have in your notes that its E value was 1.10 volts. So if we wanted to know the delta G of this equation, we would simply put delta G equals negative. If we look back at that equation, how many electrons are being transferred? Well, we had 2 moles of electrons being transferred. So it's going to be 2 moles. And we're going to multiply that by 96,500 coulombs per mole. Alright, so our mole is going to go bye-bye. And then our voltage was 1.10 volts. Alright, so if we look at units real quickly, moles go away, and a coulomb times a volt is a joule. Alright, so we would get an answer that would be around negative 202,300 joules. But delta G is usually written in kilojoules, so really we'd have negative 202.3 kilojoules. Alright, so just an example going from E cells to delta Gs. The next thing we're going to look at, get some more room, is going to be letter C, and we're going to relate E to equilibrium constants. Relating, I forgot an I there, relating E cells to capital K's, or equilibrium constants, which we've been dealing with the last couple units. Alright, and this, essentially what's going to happen is we're going to combine our equation up here, which was delta G equals negative NF E cell. We're going to combine that with our equation from, I guess, 2 units ago, which was delta G equals negative RT ln K. Ln K. Clean that up. Negative RT natural log of K. Alright? And if we set those equal to each other and solve for E, we're going to get this equation. It says that E cell equals RT over NF ln K. Alright? And a bunch of these end up being constants. R is a constant, F is a constant. T, if we're talking about standard conditions, so we put a little knot here, T is going to be 298 Kelvin. And all this can kind of be simplified into these 2 equations, which you're going to see on your equation sheet. And depending on whether you want to work in log or natural log, we can say that E equals 0.0257 volts over N moles, okay, and that's just moles of electrons that are transferred, ln K, or that's the same as 0.0592 volts over N log of K. And again, whichever one you would prefer to work in, again, this relationship between 0.0257 and 0.0592 is related by the constant 2.303, alright, which is our conversion between log and natural log. So with these equations, these are true at 298 Kelvin. Alright, and again, we're just going to do an example. What is the K value using, again, our zinc copper equation, which we have from above? So once again, our voltage was 1.10 volts, and we're just going to use, we'll use the natural log one. So we're going to have 0.0257 all over 2 times the natural log of, and we're trying to get the natural log, so let's say natural log of K, and we can change this just into, our voltage side is going to become 85.6 equals natural log of K, or we're going to have E raised to the 85.6 equals K, or really K equals 1.5 times 10 to the 37th. Alright? And you can see, again, a positive voltage gives us a really, really big K value. And what does a really big K value mean? A really big K value said it's heavily, heavily product favored. If it's heavily product favored, it is typically spontaneous. Alright? So again, a couple more units. Joules is equal to volts times coulombs. We have a new constant called Faraday's constant, which is 96,500 coulombs per mole of electrons. And then whenever you see an N in an electrochem section, such as this N right here, this is always going to be moles of electrons transferred. Alright, so in our second equation from podcast 14.1, where we had the magnesium and the aluminum, that had 6 electrons transferred. If you fun stuff, easy stuff, math-related stuff, which again relates electrochemistry stuff back to spontaneity, which is thermochem, and K, which is equilibrium.